An ultrasound detector connected to an oscilloscope can be used to find the thickness of a layer of muscle. Now here is the oscilloscope screen, and we've sent out a transmitted pulse. This is the first pulse here, and we've received a reflected pulse a little time later. Now each horizontal division in this oscilloscope trace represents 2 microseconds. So each horizontal division, that's each of these squares, represents 2 microseconds. And we'll see in a moment what the prefix micro means. The speed of sound in the muscle layer is 1,585 meters per second, and we've got to calculate the thickness of the layer. So what we're going to do is do this step by step using a process called do less, which is a great way to structure calculations. D stands for diagram, L stands for listing your data, E is select the right equation, S means sub in the numbers, and S at the end means state the answer with the units. So let's first of all take a look at what's going on here. So we've got an ultrasound transmitter and receiver, and we're investigating the layer of muscle. So we might have a ultrasound transmitter and receiver, and that's being placed on the area of the body under investigation, and we've got a layer of muscle just here that we want to know what the thickness of that is. And the ultrasound transmitter will transmit some ultrasound pulses of sound, and we'll get a partial reflection from the muscle layer because it's a different type of material with a different density in it. And so our ultrasound pulse has traveled there and back again. So whatever distance we calculate, we must divide by 2 to get the correct thickness of this muscle layer. So the first thing is diagram. So that was D for diagram, and it's a useful thing to do just to get your head around the question. Secondly, we're going to list the data. So let's L for list. What do we know? Well, we know that the speed of sound in the muscle layer is 1585 meters per second. So I'm going to write speed equals 1585 meters per second. We want to know what the distance is. So distance D equals question mark, and that's going to be in meters. It's always a good idea to show what units you're working in at the listing stage. We know speed, we're trying to find distance, and what else do we know? Well, we know the time that the reflected pulse came back. And each of these divisions is, I think we said it was 2 microseconds. So that is 2 microseconds from there to there. And what is a microsecond? So let's just put T equals 2 microseconds. That's the symbol for micro. Now that's a prefix, and it stands for times 10 to the minus 6. So we have to convert to the correct units here so that the units agree. Seconds agree with seconds, meters agree with meters, and we're all set to go. Okay, so now it's time for equation. Select the right equation involving speed, distance, and time. Now, some people use triangles to do this. So there's a DST triangle, DST, which you can use. So you just cover up the quantity that you want to find. So in this case, distance is what we want, and that's going to be speed times time. Another handy hint is if you look at the units of speed, you find that it's in meters per second. That's distance, meters, divided by time. And let's take a look. If we cover up speed, distance divided by time. So that's another way of getting the equation if you're not sure. You look at the units. So here we've got distance is equal to speed times. In fact, I'm going to write speed as a whole word because sometimes we use the letter S for something called displacement, which is a type of distance. But we're just going to stick with distance, speed, and time like this. Now we put the numbers in, we sub in the numbers. So distance is equal to 1585 times by 2 times 10 to the minus 6. And if we take a look at that, we find that we're going to get 0.00317. And remember now that we have to divide by 2 because it's a round trip. So our distance, if we carry on up here, muscle layer thickness is that divided by 2, and we get 0.00159. Now this is in meters, and it's probably better to put this into millimeters. So if you times this by 1,000, we can convert meters to millimeters. So the decimal place will move 1, 2, 3, and we'll get 1.59 millimeters. And that is the thickness of this muscle layer as found by this ultrasound transmitted pulse and reflected pulse.